Afternoon to all my friends. Thank you, ma'am. And first of all, good afternoon to all my friends who are waiting for me and ready to listen me. In fact, so although I keep on teaching variety of the subject related with the energy efficiency, decarbonization, sustainability, environmental impact assessment, all those things, but nowadays there is a desperate need of the power system, that is appropriate energy storage system. So we'll talk I'll talk on that. And ma'am, I believe I'll get 1 hour or more. Accordingly, I need to adjust my presentation because I've got some 60 slides
No
in
problem.
hands.
No problem. You can take your time. Because
So in fact, this subject is such an interesting subject. I'm sure that you will also like. Let me share the screen and files first of all. So let me start from the scratch. In fact, I hope slides are visible.
yes, it is visible
in the full screen mode. Now better, I think. Yeah. So here I'm not only going to talk about the electrical energy storage system, because the first thing which comes in the mind is the battery when we talk about the storage. So while battery as on date across the world is a very small component, in fact. So let us discuss one by one in the structured way why there is a need over there. So of course, for renewable, our country's goal is to become net zero by 2070, or at least 50% of the energy to be produced by renewable energy sources or green sources by year 2030. So that is almost next to impossible, because in last so many centuries we could reach to 26-27%. And I just share one small data. In last summer, it was one of the hottest summer. I believe every one of us felt that summer. And in this summer, our installed capacity of India is approximately 400 gigawatt hours, you can say. While the peak was 200 gigawatt hour, and before peak, our grid was stumbling. In fact, so we are able to utilize even less than 50% of the resources what we have got in hands. So why it is so? Because we are having plenty of the renewable energy sources, which that energy is available when it is not required or less required. While when it is required, then renewable is not available in the abundance, you can say. So basically, renewable is which we follow in Hindu mythology. हमारे वरुण देवता, सूर्य देवता, जल देवता, all these are renewable energy in fact. So ये इन देवताओं की कृपा जब होती है तभी हमें वो एनर्जी मिल पाती है. So in daytime we get the plenty of solar, we can harness that, but on an average 5.5 hour per day, you can say, throughout the year. Or wind is one of the most unpredictable, or hydro. Small hydro can cater the local areas, but it cannot. For grid applications, we require the megawatt or gigawatt range hydro plants, so big hydro plant, which requires a huge investment and infrastructure like dams and all those things. So we'll further discuss how we can cater this problem. And another is like our grid stability and grid resilience, you can say. That is very much important, and especially when plenty of distributed energy resources are there. Like after Electricity Act 2003, the open access has been allowed in India to anybody. So now anybody can produce energy at any place, and it can export to the grid. Of course, the due diligence is required, or statutory requirement need to fulfill. But it is now available, and so many good, I will say, the guys who are having plenty of surplus money, so that they are preferring to invest for the green energy. You can say solar projects, wind projects, or hydro projects, or biomass projects, or whatever is there. But the thing is that these sources are distributed energy sources. So these are getting inserted in our grid, which is existing grid, we can say. and existing grid is not that much strong like developed countries or European countries. So we face plenty of the breakdowns and maintenance problems are there. So whenever any energy source is inserted, it creates the turbulence in between, you can say, in the power system. So that is a very important part, because for avoiding outages or maintenance and all those things, it is also very important. And this can be solved up to certain extent by the battery or storage, you can say. Next is, of course, storage means it is contributing for the emergency preparedness. Like from the years together, maybe we can say 5-6 decades, we use the battery backup as an emergency lighting or emergency fan or household inverters or something like that. So, and nowadays, when we are talking about the lesser emission or zero emission, then we are encouraging the electric vehicles, you can say. Of course, the electric vehicle is beneficial if it is charged by the green energy. Otherwise, it is causing more carbon footprint, rather, I'll say. But still, when we have to charge, when we have to integrate with the grid, then we require appropriate stable system. Otherwise, we cannot do this kind of activities. So we can say we have got adequate energy storage technologies will enable, if we want to become energy surplus, or our we want to make a balance between supply and demand, then without a storage system, we cannot think of. We means not only India, across the world. So world cannot think of, even our net zero goal never can be fulfilled unless we use the appropriate energy storage system. That is one of the biggest problem. So what are the problems? We'll discuss one by one. What are the types? What are the solution? We'll discuss. Before that, let us have a look on that. What is the pie chart, or we can say where the storage is being utilized as on date. As on date, I'm talking about that, you can say. So our household inverters are using approximately 44%. Telecom towers are using around 19%. UPS is using around 15%. And then grid scale solar plants are using 7%. I'll discuss in detail also the grid scale solar. Nowadays, all government tenders are coming with the quote like RTC, round the clock. So whenever any solar plant of megawatt range as an independent power producer is required, it simply mentions we want the power for 24 hours while it is solar plant, or we want the power for 16 hours while it is a solar plant which can provide only for 6 hours. So for rest 10 hours without storage cannot be thought of. That is one of the biggest application of the storage, you can say. PTM rooftop approximately 3%, grid scale wind storage approximately 3%, diesel replacement approximately 1%, HVAC, that also I'll discuss in detail. Like in commercial building, efficiency of the building can be increased, or energy bill can be reduced with the help of the appropriate thermal storage system, you can say. So let us discuss one by one. So this is a broader pie chart of the storage currently applicable across the world. We can see around 92% is pumped hydro storage. I strongly believe most of us might have not heard, but across the world, 92% storage is in the form of pumped hydro storage, which I'll discuss in the next slides or further slides. And compressed air energy storage is around 0.2%. Molten salt, which is used in concentrated solar power plants, you can say 1.8%. And flywheel is also one of the options, which stores the energy in the mechanical energy in the format of the rotational form. That is around 0.2%. And the storage which we are familiar, that is electrochemical storage, what we call is battery. हमारे बैटरी बहुत तरह के होते हैं, and out of these batteries, lithium ion is the winner. So gradually, after by the end of the presentation, I'll give some sufficient data that how lithium ion is the winner. That is, the 2-3 main features are there. Like its weight density is less, means it is having good application in the mobile applications like laptop, mobile, or smaller applications, you can say. Why smaller? It can be used in the big also, but it is a costly affair. Lithium is also one of the rare metals, you can say. So that is another big problem. And the sodium sulfide battery is around 5%. Lead acid battery around 4%. flow batteries, iron flow batteries around 1%, supercapacitors less than 1%, and others are also there. Some trials, some details are working over there. I had not mentioned here hydrogen. That is a new development. Still, it is under testing and for commercial application. And I'm sure within maximum 2 years, this is my personal opinion, within maximum 2 years, we'll be banking upon the hydrogen energy and the storage of the hydrogen. In fact. So that's the future of the energy. I'll discuss in the further slides. Why it is not, yeah. So if we talk about the maturity of the different storage technologies, few technologies we know from the years together. Few are in the demonstration mode and few are like early stage of the technologies, you can say. So already deployed one is pumped hydro, as I shown 92% is pumped hydro, compressed air energy storage, batteries like sodium sulfide, lithium ion, lead acid, and flywheels. And then the next category is demonstration. These are still to be proven, you can say. So under trial or maybe partial for some projects and all, this is being used, already in use, in fact. Advanced lead acid or ultra lead acid and flow batteries, and then superconducting magnetic energy storage and electrochemical capacitors. These are mainly used, you can say, in EVs, you can say. And some early stage technologies, as I reported, that adiabatic compressed air energy storage is another good form of the compressed air form of the energy storage, which has got a very good efficiency because it recovers the heat as well. So, and the hydrogen, as I told, as per my knowledge and calculations, hydrogen is going to be the biggest winner in next 1 to 2 years, I can say. As on date, that cost of the producing hydrogen is has come around $1.5 per kg. The moment it touches the $1 per kg, every vehicle, everywhere else, anybody will start using the hydrogen. So, and another one is synthetic natural gas, which is of course one of the cleanest fuel. So after hydrogen, I will say the second priority is there, but it has got limitation in the resources. So quantity available is very less, you can say. Yes. So broadly classifying the storage technologies in 5 categories. First is mechanical, second is electrochemical, third is thermal, fourth is electrical, and fifth is hydrogen-based storage. So when we talk about the mechanical, that is pumped hydro energy storage, as I told earlier also, gravity storage technologies, compressed air energy storage, and flywheel. These are the 4 formats of the mechanical energy storage. And one by one, briefly, I'll discuss considering the time constraints. Electrochemical is simply battery, what we call is battery. Lead acid advanced lead acid battery, lithium ion battery, and flow batteries, and high temperature batteries and zinc batteries. So many variety of the batteries are there. We'll discuss the pros and cons of some of these batteries in this presentation. Thermal is another good format of the storage. Yeah, that is, of course, thermal energy, either it can be stored in the format of sensible heat, or it can be stored in the format of latent heat. And third is thermochemical storage. That is basically reversible chemical reactions. Like chemical reactions are 2 kind of the reactions. Either it is endothermic or exothermic. Endothermic means it absorbs the heat. Exothermic means it releases the heat. So some reactions are there which are fully reversible, like when one side it is taking place, it is absorbing the energy, and when the other side or when the reverse reaction is taking place, it is releasing the energy. So that is another good format, but not very popular in limited applications, of course. And electrical nowadays, supercapacitors are used for like it has it can be used to provide a big energy for a short moment, you can say. So superconducting magnetic energy or supercapacitors, these are used in some of the EV applications and all, where we require sometime extra torque or boost or something like that. In those applications, they use the supercapacitors. And hydrogen based storage, nowadays there are less application, but future of the energy, what I can see, it's my personal opinion, of course, it is hydrogen based. Yes, of course, 2 technologies need to be cheaper. that is fuel cell and electrolyzers or electrodes of the electrolysis process, you can say. So what are the challenges in the widespread deployment of the energy? Cost competitive energy storage technologies are required. That is obviously the job of the engineers is not only to develop the technology, it is to develop the technology with the commercial viability, of course. Unless it is commercially viable, it will remain in the showcases or demonstration projects. So life cycle cost and performance, how is it? Round trip efficiency, how is it? Energy density, how is it? Cycle life, how is it? Capacity fade, how is it? So different characteristics are required in the battery, which we expect, and validated reliability and safety is required. Like from last 4 5 days, I am seeing one video is moving in the this, you can say, WhatsApp. That is a person carrying a scooty battery in the lift and it got busted. So even one of my friend today was asking, was it because of the lift? Then I made him clarity that it doesn't have any relationship with the lift. It is simply like there are positive and negative electrodes, and because of the manufacturing defect, there may be some short circuit and it got blasted or sparks have taken place. And then maybe in the lift inside, there may be the paint which was highly inflammable, which has caught the fire and all those things. Anyway, and second is when you are in lift, of course, you don't have any option to escape. So if it could have happened any outside, the person might have been saved. Anyway, that's a safety issue. In last of these slides, I'll discuss about the battery regulations also. So there we'll discuss about the safety issues and other issues. So equitable regulatory requirements are there, like value proposition for the grid storage depend on the reducing institutional regulatory hurdles to level comparable with those of the other grid resources. Of course, earlier there were no regulations, laws, or diluted regulation laws were there related to the battery. In India, the battery management law first time has been brought in year 2001. Then in 2010, the amendment has been brought, and then in 2022, that has been made quite stringent. So now there are tougher norms related to the battery that also, if time permits, we'll discuss briefly at the end of the presentation. Industry acceptance, that is over and above any damn thing. In fact, when we talk about the commercial viability or commercial popularity or for any engineering product, it depends on the acceptability of the people and industry. So acceptability of the people and industry means how comfortable and convenient is the technology, and over and above, what is the price costing to him. Life cycle cost, you can say, not only the buying cost or running cost, you can say. So required key characteristics of the any storage is like rated power capacity, energy capacity, storage duration, cycle lifetime, self discharge, state of the charge, round trip efficiency. Of course, some of these characteristics we are checking from so many years, which the mobile has taught us, in fact. So mobile has taught us so many things. Beside this, most of us are facing problem like my mobile is getting discharged quickly, or even in standby mode it is getting discharged, or it is heavy, or the phone is heavy, so the thing is, when we talk about the battery, again it is dependent on the application. So if my application is static, like if it is grid based or maybe mass storage, you can say, then I can compromise with the weight density. Then I won't see the weight, what is the weight. Of course, I will see what is the energy density, means how big charge it can store. That is more important. Second is, once I charge that and I'm not using, so I expect it not to get discharged quickly. So if I'm not using the battery, if I'm using battery as a backup, I want my battery should remain fully charged unless I allow, or unless maybe month long or hours or something like that, you can say. Second is, it depends on the round trip efficiency. Round trip efficiency means in overall charging and discharging, if I'm losing some power, that is round trip efficiency. So ideally, we should not lose any power, but technically, all these charging discharging devices are using the power electronic devices. Those are thyristors, tracks, or IGBT or MOSFET or something like that. So these devices nowadays are faster, but it consumes a lot of energy. So here the point comes is we need to compromise or optimize between speed and charging capacity, you can say, or rate of charging, you can say. So हमको अगर तेज चार्ज करना है तो हमको फिर ये एंड दिस हीटिंग प्रॉब्लम्स भी आएंगे, लॉस प्रॉब्लम्स भी आएंगे, सब कुछ आएंगे. So we need to take care of those things, in fact, है ना. So that is one thing. Now some more the thing is where we apply this energy storage system. First is of course arbitrage. That is backup to the power, you can say. Power चला गया तो हमको बैटरी से बैकअप मिलना चाहिए. Or renewable energy curtailment. This is what I started my session, that if we want to run our country with the renewable energy, not only country, the world with the green and this, one side we need to act on the energy efficiency, like reducing our demand. Second side is that the renewable energy capital, it attracts a lot of capital investment. So it we can manage with the lesser renewable energy sources if we are having appropriate storage system. Of course, another interesting thing is the moment we include the storage system, the price of the solar projects or wind projects goes 1.5 times. So that we need to optimize. So actually, let me summarize in one line. The world is looking for the solution, the cheaper and bigger storage at low price. Of course, that is what the solution we are looking for. Nowadays, batteries are very costly, of course. So firm capacity for the peaking capacity. When the peaking capacity is required, then the backup should support, and we should be able to manage the whole demand with the lesser power sources if we are having appropriate energy backup or energy storage system. Operating reserves and ancillary services. This is the practice used from the years together in hydro plants or in other thermal power plants and all those things. Operating reserves are in the form of the storage. Transmission and distribution upgrade deferrals. This is what is the new things where so many engineers and scientists are working for making the grid resilience and for making the grid more stable. They are using the energy storage systems so that if some source is injected or some source is getting out, it doesn't. Our power grid should not fluctuate, or our grid should not get unstable. In fact. And black start is common and on-site when we start any system like power plants or anything. Then without battery, the machines cannot be started. Once it is started, then it is a perpetual mission. We are getting sufficient energy to fulfill the requirements of the continuous need, you can say. So in one chart, I try to compile this grid storage applications. You can say high energy to high power. There is a difference. What you want is depends on that. In case of grid, you want high energy or high power, but energy storage is required in both the cases. Like in high energy management will be done by energy storage. Decoupled generation from the demand will be done by the energy storage. When we require the high power, then power quality will be maintained by the energy storage system. Then improved grid resilience will be through the energy storage system. And the discharge durations depends on seconds to hours. How long? In fact, when we talk about the size of the storage, then size of the storage is depending on the how much power you want for how much time. So in totality, what size of the energy do you want? You want for seconds or minutes or hours? So different kind of the applications are there for energy storage system. For especially for grid, we want the backup for the hours, you can say, for load leveling, for peak shaving, for energy trading, for island operations, or for integration of the renewables. For all those, we want a huge backup, in fact. And for minutes, we can manage with a small other storage like synchronous reserves or uninterruptible power supply or black start. And for seconds, that's a very common one, like emergency lighting and all those things, small or transient smoothing or reactive power control and voltage frequency regulations. So this is one chart which is showing you the existing need not affected by new trends and the old one need affected by the rise of the renewables. So basically, dark orange is the thing which is expected to rise if we insert more renewables in the system. So that is what my first statement was there. In fact, that we are thinking of going for the net zero with the help of the green energy and clean energy, and we don't have sufficient energy storage to cope up or to comply for that. So this kind of the applications will be required. Like black start, as on date also we are doing with the energy storage. CHP output optimization we are doing with the energy storage. Peak shaving we are existing, and backup power is also existing. But all other things like avoid spilling energy, maintain voltage level, maintain frequency, follow load, network reinforcement deferrals, correction of the forecast inaccuracy, wholesale arbitrage, retail marketing arbitrage, renewable energy self-consumptions, off-grid. For all these applications, we require appropriate energy storage system. So now I think you are seeing the broader picture. How important is this energy storage system? So we are thinking of big things, EV, this, that, and renewable energy, net zero. We are talking about so many things, decarbonization, ESG, and all those things. While the biggest barrier is this appropriate, economically viable storage system. So here is another good comparison. On x-axis, this is system power rating or module size. On y-axis, this is discharge time at rated power. So in starting, we have seen that pumped hydro is one of the most popular. Why it is? We can see from this chart. So it can supply the backup for the hours together with a huge, maybe 5 gigawatt, 10 gigawatt, 20 gigawatt. Even I am right now sitting in Dehradun, and nearby is a Tehri Dam. In fact, Tehri Dam, they've got a pumped hydro storage. They are trying to commission from 1 decade, which is approximately 10 gigawatt hour. सो 10-12 साल तो हो गए इनको, अभी तक कमीशन नहीं हो पाया. इट्स another thing. So I'll discuss that also. How many hydro plants right now, or how much pumped storage in India is working, but globally it is, and obviously, like the oldest renewable energy format is the hydro energy, which started some 2 centuries ago, and all those things. So when the hydro storage, this hydro energy started, then after some time, people or engineers devised the things in daytime. Or when the water flow is there, we can run the turbine, we can generate the excess energy, and we can run the pumps, and we can send the water back to the high altitude, you can say. And when it is required, it again can be taken to the downside. That is the pumped hydro, you can say. So basically, when there is a surplus energy, we are running the pumps to send the water to the upper level. And when there is a low flow in the hydro plants or anywhere, then of course we flow that conserved water, and then we generate the same energy. So that is a pumped hydro, in fact. And the flow batteries are not good for the mobile application, because weight density is very high. But these are now getting popular, iron flow batteries and all, because iron is also cheap for the grid applications or broader applications where hours of the backup is required in megawatt range, you can say. Compressed air energy system has is getting omitted gradually, because compressed air system itself is one of the most inefficient system. So generally the efficiency of the compressed air system is 5% to 15%. As an energy auditor or as an energy professional, I always discourage to the use of the compressed air energy. In fact, that is, if I am administrator, I will declare it as a crime, the use of the compressors. It wastes 85 to 95% energy. It is hardly 5 to 15% energy utilized and all those things. But it's still in older time, these are the storage used. Then the sodium sulfide battery, advanced lead acid battery, sodium nickel chloride battery, high energy supercapacitors, lithium ion battery, lead acid battery, nickel cadmium battery, nickel metal halide batteries, high power flywheels, high power supercapacitors, SMES. So with this chart, you can have a just idea to choose for which battery may be right for your application. Your application means for which application, I'll say, rather correcting that. Like if you want the longer time backup and bigger power, then you have to go accordingly. Or if you want to have a just few second backup, and cheaper solution, then of course you can go for the lower storage devices, you can say. This is a diagram showing the pumped storage hydropowers. These are two kind of the pumped storage hydropowers, open loop or closed loop. In closed loop, there is a fixed reservoir. In open loop, there is a river flowing and water we are continuously sending to the upper altitude or bigger altitude, you can say. And when it is there is a shortage of water, then of course we take it down. So like in winters, generally there are less water in the rivers, and we flow it and we recover that energy what we send in the summer time or and rainy season time, you can say. These are some of the characteristics why pumped hydro storage is so popular. The pros is projects may be practically sized up to 4,500 megawatt. Round trip efficiency is around 76 to 85%. Long, long life cycle on the order of 50 to 60 years. Rather, as per my knowledge, there are some pumped hydro storage of more than 100 years also available in the world. General rule: a reservoir 1 kilometer in diameter, 25-meter deep, and having an average height of 200 meters would hold enough water to generate a 10,000 megawatt hours. Good enough. So 10 gigawatt hour is good enough to supply for the few days, you can say. Currently, most cost-effective form of the storage. Limitations are there, that is specific geographic requirements. It is not possible at every place. It is possible where there is a huge flow of the water, maybe hilly areas, or maybe the where the altitude difference is there, or where the level difference is there, or where the surplus water is there. So it is geography specific kind of the projects, you can say. There are environmental impacts because wherever these dams are created or hydro storage are created, it affects the local species, you can say, because of the storage. Some species get killed and all those things. And high overall project costs. The project cost is very high, so it attracts a big capital investment. Timely applications are like energy management, backup and seasonal reserves. As I told, it's a seasonal reserve. Regulation service, variable speed pumps, black start provisions. Regulation service means, like for power plants, there are regulations. Earlier, they were not maintaining the voltage and frequency and all. We were observing plenty of the voltage and frequency fluctuations. Then the stringent laws came by Government of India, I think some 8-9 years back or something like that. And as per those laws, this power generating company or power selling company is not allowed to make much deviations in the frequency and voltage. So when there is a water shortage in the hydro plant, then they fulfill the requirement through this water reservoir pumped hydro storage and try to maintain their voltage and frequency. That is what is there. So this briefly is the India's PHP statistic. Two projects of 1,080 megawatt capacity are now under construction. 1,000 megawatt, as I told, Koina 80 megawatt, and 4 projects with the cumulative capacity of 2,600 megawatt are under planning. However, at a given point of time, many of these assets are either under maintenance or are no water release only. So the thing is, as on date, practically we don't have pumped hydro storage, you can say. This is a graph which will give you a better understanding. Of course, this is a winning jugaad, I'll say, pumped hydro storage. It's not technology. But the thing is, it attracts a huge capital investment, and before that, it requires a very rigorous environmental clearance, in fact. So nowadays, for any big projects or mega projects or government projects, there is a high emphasis and very stringent norms for environmental impact analysis. And unless the EIA report is clear, they cannot make any such projects and all those things. But the other technologies are there, of course, as a substitute. Compressed air is also costly. In compressed air, we store the compressed air under the ground, you can say. We make the cavern inside the ground and we store that compressed air. And high energy capacitors can provide small power, long duration. Flywheels also can provide for short durations and small powers. High power capacitors, high flywheels, superconducting magnetic storage. So now we'll discuss some of these technologies. So compressed energy storage is generally used for the turbines, you can say, running the turbines. So when the surplus power is there, we run the compressor and we store the high pressure air inside the caverns mesh inside the earth. And when we require to run the turbine or any other machine, we release the pressure and really, run the turbines and generate the energy. So that is a simple process in the compressed air energy storage. Of course, as we've seen, around 4% across the world is this only. So it can be two kind of the things, like if you are having waste heat recovery system or not, because compression of the air is a adiabatic process. So whenever we compress the air, as per Boyle's law, Charles' law, the temperature also rises of the compressed air. So as such, if you are using that air, then we are wasting that heat. So it's advisable to put the waste heat recovery system inside that, which stores the heat as well. So using doubly, it further enhances the efficiency of the system, in fact. So types of compressed air system is, one is normal, diabatic, or adiabatic. Adiabatic, so diabatic is having the efficiency approximately 42% without and 55% with waste heat utilization, while much higher efficiencies are there in adiabatic system, that is around 70%, you can say. Again, the locational disadvantage is there with the compressed air energy system. Wherever we want to store the energy, it requires a huge area, and generally it is suggested to have it outside of the urban area, you can say, because the compressed air system has got regulation that it has to be away from the population. It can burst anytime. It is quite hazardous also. So for complying those regulations, these are generally in suburb area or outside of the cities, you can say, or maybe remote areas. So better ramp rates than the gas turbine plants. Established technology in operation since 1970s. Life cycle on the order of the 30 years and starting time approximately 10 minutes. The limitations are there, geographically limited, as I told. The compressed air system cannot be kept in the close vicinity of the population because there are hazards of bursting and all those things. Slower responses time than the flywheel or batteries, and environmental impact is there. Lower round trip efficiency is there, 50 to 60%. In case of adiabatic, of course, it may go to 70%, you can say. Primary application is like energy management, backup and seasonal reserves, ancillary service provisions, and black star provisions. So this is some of the data. What has been planned or has been done in India. Total electricity demand in India is estimated at 109 megawatt annually, and underground CAS energy storage capacity potential stands approximately 10 times greater than annual demand. But this is what is potential. The potential is not even 1% being utilized. The reason is obvious. It costs the energy. It attracts a huge money. It has got the safety limitations. It requires the place which is outside of the populated area, or these kind of the problems are there. So battery energy storage devices can be differential. Now I'm coming to the one of the most popular format which we understand as a storage, that is battery. So in battery, two major features we expect, that is weight density and energy density. That is, it should be lighter and it should have more and more power in a small module, you can say. And of course, the other characteristics are there: charge and discharge efficiency, lifespan, eco-friendliness of the devices. How eco-friendly is this? And lifespan is what? And of course, efficiency, charging, and all. So battery storage qualifications, if we talk about, like lead acid batteries, there are the characteristics of the lead acid batteries. So lead acid batteries are the oldest and the most mature technology. This is low upfront cost, high reliability and efficiency, like 70 to 80% efficiency we can get out of that. The limitations in terms of the short life cycle, which we have seen in our life also, if we are having inverter or some backup and all those things, that after 3 year or 4 year, we need to replace the batteries. Even in cars also, we need to replace after 3, 4, 5 years. Low energy density, that is one thing. And environmental friendly, of course, lead is not environment friendly. That is why there are regulations and rules that if you want to return back the lead acid battery, means if you want to buy a lead acid battery, then you can buy only if you are selling it. And even if you are first time selling it, then also the seller is responsible for that. So as per battery management regulations of 2022, the it is the key responsibility lies with the supplier or exporter, importer, whomsoever is importing or whomsoever is producing. They are responsible to keep the accounting of those batteries so that by this heavy metal lead, our land is not contaminated. It is appropriately recycled. That is what is important in case of battery, lead acid battery. So sodium sulfur is another manufactured with the molten sodium and liquid sulfur. Key application include the spinning reserves, frequency regulations, energy time shift, and transmission cogeneration relief. In India, sodium sulfide battery was trial tested by NTPC for its reliability and Indian grid conditions in a solar system. In solar system, they are demanding the sodium sulfide battery. In fact, that is a preferred choice. And nickel cadmium battery, we are hearing from a long time, that is rechargeable cells, what we are using in our small devices. These are nickel cadmium. It is of course similar like lithium ion, but of course little costlier than that. So some no special feature is there better than lithium ion. Rather, it is costly. That is why it is not popular. It is not the winner in mobile and laptop and all other flexible applications, you can say. So nickel cadmium batteries are known for their robustness, reliability, and service life. The beauty is they have got the better service life. The efficiencies are 60 to 80%. Lifespan can range to 10 to 15 years. While in lead acid battery, it is hardly spanning to 3, 4, 5 years or something like that. So these batteries have life up to 1,000 charging discharging cycles, can respond to a full power within the milliseconds. And high cost, low energy density, high self discharge rate. These are the special features of the nickel cadmium batteries. Another is nickel metal halide batteries. It is also similar like nickel cadmium. Only thing is, instead of cadmium, cadmium is also a heavy metal. So that also contaminates the lands. So we avoid the cadmium for environmental concerns. We avoid the use of the cadmium and lead. In fact, in lithium, nickel metal halides, this is like nickel bromide or nickel chloride and all those. These kind of the batteries are there. The only difference between them is that instead of cadmium, hydrogen is used as the active element. Price and safety advantages over the lithium ion batteries, and compared to nickel cadmium batteries, they have 25 to 30% higher energy density, less prone to memory effect, and are environmentally friendly. So memory effect is what? If like the batteries are having small cells, so the way it is being used, it gets stored in the memory of the cells, you can say. So accordingly, the this starts behaving. So, and you might have experience in your life also, if you are not using the mobile for the 10 days, 20 days and all, you'll find that the mobile battery starts misbehaving and all those things sometime, if it is kind of the nickel metal halide and all those things. So limitations in terms of the higher cell discharge rate, low energy intensity, and deteriorates the during long time storage and should not be stored at high temperature. So different options we discuss, but again I am coming to the winner, which is one of the most popular. That is lithium batteries, deemed one of the most promising solution for both large and electricity storage systems, small scale. Types of lithium-ion batteries are like lithium cobalt oxide, lithium titanate oxide, lithium manganese oxide, lithium iron phosphate, lithium nickel manganese cobalt oxide, lithium nickel cobalt aluminum oxide. So these are different metals or metal alloys used in those batteries, and there are slight difference in the characteristic of batteries made by these different metals, you can say. So not big difference, but you can say general characteristics are these what I am sharing. High efficiency of over 90%, and which we see in our laptop, mobile, of course. Long life cycle of 1500 to 2000 cycles. High energy density of 200 watt hour per kg. Lowest self discharge, 5 to 8% per month at 21 degrees centigrade. 15% at 40 degrees centigrade, and 31% at 60 degrees centigrade. No memory effect. Discharging time ranging from the seconds to week, making it more flexible and universal storage technology. It is, you can say, iron flow battery, better option over lithium for grid scale storage. As I shared earlier also. So lithium ion is a very popular because mobility is possible. It is weight density is also less, as well as it is less hazardous, and it is less voluminous. So if we think of substituting lithium ion in the grid scale applications, means megawatt and gigawatt range, so then the iron flow batteries are one of the most popular, because iron is also cheap. It is nothing but it's a kind of electrolyte tanks are there, big tanks are made, and iron flow battery is built with the three pretty simple ingredients: iron, salt, and water. Flow battery has a tank with electrolyte. Think of it as a salt water to be simple, and it puts through a process that allows it to store energy in the iron and then discharge that energy over an extended period of time. So simple, this is lithium ion collected in that big tanks, and these tanks can be installed at any place, you can say. And second thing is the material used is a very cheap. Iron, salt, and water is very cheaply and readily available in the country like India or developing countries. While when we talk about the lithium ion, it is a big challenge to get the lithium. Of course, nowadays it is called as white gold. And we are lucky enough that last year a good resource has been found in Jammu area. A good storage has been found in Jammu area for the lithium. And why China and Korea and USA are ruling on this lithium EV and all, because they are having plenty of the lithium in their country. That is why. So for the country like India, in future there will be a challenge to go more for the EV and EV applications and mobility applications as well as. Iron flow batteries have an advantage over the utility scale lithium ion storage system in the following areas. This is having longer duration, increased safely, longer asset life, less concern with the ambient temperatures, lower levelized cost of the storage. These are the few advantages. And in single line, iron flow is much more commercially viable for a bigger application than the lithium ion, you can say. So for this is forecast of the estimated levelized capital cost by storage technology and type. Here we can see the dark blue one is you can say our lithium ion. This is what is lithium ion, which is coming down very fast. Unless it comes down, we cannot say. We keep our fingers crossed. So now the bigger challenge in front of EV manufacturers and EV promotion is to get the lithium and make that lithium ion batteries. Beside that, we require nickel, cobalt, and all the materials also, which are also now becoming the rare metals. So not available in the abundance, I can say. So technologies and the developments are like flow assisted nickel zinc and lithium ion batteries. मैडम जब ब्रेक करना हो 5 मिनट पहले बताइएगा, नहीं तो मेरे पास अभी बहुत सारे स्लाइड्स हैं. आई वुड लव टू डिस्कस. So flow assistant nickel zinc, this is one another type of this is what is expected in future because of the number of the life cycles. That is the beauty of this battery. And lithium air batteries, this is what is a wonderful battery. And this is invented by the same scientist who has invented the lithium ion battery some 40 years back. This is lithium air batteries are expected to make a revolutionary change in the energy storage system, because instead of the one added advantage is this has got the charge density of around 10 times than the lithium ion. So whatever is the size of the lithium ion battery, it will go 1/10 with this lithium ion batteries, you can say. So that is one of the and second is it is environment friendly. So here is another chart shown by the IESA. This is the source is IESA, that is volumetric and gravimetric energy density for the commercially available battery technologies. And as I already repeated so many times, in totality we found that lithium ion is the winner out of all these with respect to gravimetric energy density and volumetric energy density, you can say. Here is the one comparison with the energy density, round trip, lifespan, eco-friendliness. And here also it is proven that lithium ion is the first in all four things, like energy density wise, round trip efficiency wise, lifespan wise, as well as eco-friendliness wise. This is detailed chart. I think I can escape for your reference. I'll share this thing. This is about lead acid lithium-ion, sodium sulfide, flow batteries, flywheel, compressed energy system, pumped hydro system. This kind of indicative comparisons, not made by me, of course, but made by some other good agency, reputed agency. And this is for your reference. I had shared. It is further reinforcing my this that lithium ion is popular for this you can say mobile applications, and lead acid is popular when we go for the cost and kind of smaller applications, you can say. Iron flow is popular for the megawatt range applications, and pumped hydro storage is for gigawatt range, you can say. So future energy technologies, I'm talking about that, like future lithium ion or zinc air or lithium sulfide or lithium air. What I expect is will be the winner out of these batteries. And overall energy storage system, if we talk about, hydrogen is going to be winner, as I quoted so many times. So like the other part of the world, India is also having the similar problem, and being a developing country, India is having another big problem of the funds as well. So for developed countries, Europe, USA, Australia, Japan, Canada, and all those. So it's not a big issue because they are ready to spend any money. Even in 2015, when I visited Japan in JICA for the training, then our hostel was energized with the hydrogen-based generators only. And now all you can say big car manufacturers like BMW, Audi, Jaguar, and Aston Martin, and all those, they have already switched towards the hydrogen fuel because it's easy to handle with that, and there is zero emission out of that, you can say. Here is some glimpses already shared that batteries rules came in 2001, but it was quite diluted. It was just covering the protection through the heavy metals of the battery. And then in 2010, it has been modified. The rules has been made a little more stringent and more precisely. While in 2022, there is a detailed regulation about the battery waste management rules. And as per these rules, you cannot buy any battery unless you provide your old battery back over there, you can say. So that is another big issue with the I'll say electrochemical batteries, you can say. This disposal is the one of the biggest challenge with the electrochemical batteries, because in most of those batteries we are using the heavy metals like lithium or cadmium, and lead and cadmium, and those contaminate the lands. So environmental concerns are also bigger issues, in fact. So I'm skipping these applications. Of course, it is applicable to everybody else leaving the defense and satellite applications. So battery waste rule is applicable to everybody else leaving the defense applications and emergency applications and satellite applications. Because in satellites also we use a lot of batteries and all. So why I was rushing for leaving that, because I have got more important topic for you. That is thermal energy storage. Worldwide, we store a lot of energy in the format of thermal, and when we talk about energy efficiency, so simple principle lies with the energy efficiency. Lesser the conversion, more is the efficiency. So simple example, if we see like thermal power plant. In thermal power plant, we make 7-8 conversions. Like we first of all uh, 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 take the coal out of the mines, and then we lose some coal energy in the yields and all those. Then we burn it in the boiler. We get maximum 85% in the even the best boilers, and then 15% we lose there. And then we this transmit the steam. Then also we lose a lot of heat energy in the format of radiation losses and steam losses. Then we go to the conversion, thermal to mechanical conversion in a turbine. There we lose around 33% energy, you can say. The biggest losses are there in the turbine itself. And once it is converted to mechanical energy, then we convert to electrical energy. Then again, there are some losses, maybe in the range of 5 to 10%. And then converting to high voltage, another 3-4% losses, converting to transmitting that, another 15-20% losses, then again making it down. So basically, if we are using the energy in the raw form, that is the best option, in fact, I'll say. And that is thermal application. So गार्ड बांध लीजिए अच्छी तरह से, जहां पे भी डायरेक्ट हीट यूज कर सकते हैं वहां हमें डायरेक्ट हीट ही यूज करनी चाहिए. Of course, we are addicted to the electricity because our life is become lazy, or you can say we had become habitual to use the convenient form of the energy, that is electrical energy. But it is secondary form of the energy. It is converted from some other forms. So in thermal energy storage, if we can make something like that, I think some 2 weeks back, I have seen one case study in Australia. They had made a big thermal storage just using the sand. So you can say at zero cost they are storing the energy. So उन्होंने क्या किया, बड़ा सा टैंक बनाया और ढेर सारा बालू भरा उसमें, और they stored that thermal energy in that. So nothing can be better than that. So of course thermal energy can be converted, this is stored, used in two form, either in sensible heat form or in latent heat form. Sensible heat form means rise of the temperature and again taking heat back, and latent heat form is that is phase change of the material, you can say, like solid to liquid, liquid to gas, and again then gas to liquid, liquid to solid. So converting the different phase change material, we can store this. And capacity factor is another good thing, like actual annual energy production divided by the nameplate capacity, we call it capacity factor. And capacity factor can be increased with the full load hours, you can say. So as I quoted earlier also, nowadays SECI and all those are releasing the tender in the form of RTC. So round the clock they want the energy. Round the clock means full load hours, how many full load hours we can provide. So if you are an energy professional, if you'll see in any tenders, you'll find these terms, like they want the full load hours, so that how much full load hours your system can provide. And of course, it is in the IPP mode. So increase of full load hours means bigger storage. So bigger storage means it may attract the capital investment, but in case of thermal energy, the cost as compared to electrochemical or other format of the energy is very almost negligible, you can say. So CSP is another good thing, concentrated solar power plants. Some of the good plants are running across the world, in Spain also, in USA also. In it is good. CSP is good for the area where a lot of solar irradiance is there, like Middle East or Saudi Arabia or somewhere. So it is just a set of mirrors, concave mirrors, focused on a one point where they are having a tower which is having molten salt or some material which can store more energy. And that the temperature of the tower can rise up to 950 or 1000 degrees centigrade also. And then they convert that, they transfer that heat to the water, convert it to steam, and then the steam runs the turbines. This is what is basic principle of CSP based power plants, you can say. So the types of thermal energy storage, we can say, as I quoted, sensible heat or latent heat or thermochemical energy. Thermochemical energy is like chemical reaction. So the irreversible chemical reactions, one side it consumes the energy, another side releases the energy. It is a basic principle of that. So options, if we'll discuss, like in this in latent heat case, the enthalpy is constant, while in sensible heat case, enthalpy is varying. So it can be like a storage medium, can be liquid, solid, or gas, or anything, or steam accumulator, depending on the application and depending on the thermal energy available. Of course, when I am talking about the thermal energy, mostly because of the Surya Devata. So what we can harvest from the sun. So classification of storage options, if we talk about that, increasing the energy density, sensible heat storage like steam oil, concrete, molten salt, iron rock, sands, combination with the oil, liquid sodium. And we might have felt, if some of you are there in Rajasthan area or in the remote deserts, you can say. So in deserts, sand in winters it is very difficult to stand. Even in summer also it is very difficult to stand. In winters the rock and sands are too cold, and in summers it is too hot. So that is a characteristic which is used for this purpose. you can say, for transfer of the sensible heat. And latent heat is nothing but phase changing of the material. Phase changing means converting from solid to liquid or liquid to gas, or converting from gas to liquid or liquid to solid. So that requires a lot of energy which we use there. So it is a simple chart showing the global salt, hypo, paraffin, ice, calcium chloride, hexahydrate. So some of the phase change materials are these, which are very popular in the phase change material of the thermal energy storage, as you can say. So now I'm coming to the one interesting application which is very much applicable for the commercial buildings, you can say. So in commercial building, the biggest load is air conditioning load. Approximately 60 to 70% load of a commercial building is air conditioning load. And air conditioning, it is not for saving of energy, but it can reduce the electricity bill. Like when the electricity is cheaper, like in night time of peak hour, when the electricity is cheaper, then we can store we can run our air conditioners and we can make my office cool or my building cool. And when there is electricity is costlier, then I'll switch off my ACs. And the same thing has been used in your refrigerators as well. If some of you have bought the refrigerator in the last 5-7 years, you might have seen there are some gel cassettes in the freezer. So those gel cassettes are nothing but these kind of the materials and applications. So if the electricity is not there, the fridge remains colder for 4-5 hours with the help of those kind of the gel applications. So it's basically in one line, in technical terms, we can say the load shifting is. So when my energy is cheaper, I can use that, and when my energy is costlier, I will stop chilling that, and this is highly applicable for the warehouses. So in India, there's a huge amount of energy is being used in the warehouses. In warehouses, this kind of the things are really beneficial. Like if the powers are not there, then of course it will maintain the coldness of the warehouse or refrigerator or chiller or something like that. So there are different materials used for that, is chill water system or ice system or electric salts. And brine is also very popular in the sub-zero applications in warehouses where we maintain with the -5 degree or -20 degree. So in off season, the foods we store in the sub-zero temperature, then it is really good. Here is a very small comparison with the cold storage mediums for you whomsoever want to use. You can use this chart for evaluating the kind of cost and the material what you want to use, in fact. So benefits, as I told, it's a reduced equipment size, it's a reduced capital cost, it is a energy cost saving, it is energy saving, it is improved HVAC operations, and it's a full standby capacity and allow free cooling and all those things. It's a backup of the cooling, in fact. Disadvantages are also there, of course, but those are small. IGE storage system use 15% more energy than the conventional plant due to the lower operating coefficient of performance. So if our chiller is efficient enough, then of course this is getting will get more benefits out of that. So overall efficiency we get around 85 to 90% in that, because we lose some energy in the pipeline and heat exchangers in the air conditioners and all those things. Thermochemical energy system, I already briefed. This is nothing but like one reaction as shown. So this reaction we have commonly seen in our houses also when there is a painting going on. We buy the tuna from the market, calcium oxide, and then we react with the if we put in the water, it is bubbling and all. That's the exothermic reaction. So that similar reaction takes place in the reverse process. So if you are putting up the calcium carbonate in the water, it is releasing the energy. And if you are other ways, reversible process, it is absorbing the energy. Let us escape this. And briefly, I would like to explain this hydrogen storage. Hydrogen is actually, as I quoted so many times, in my opinion, it is going to rule the world. In fact, in next 2 to 3 years maximum, rather within a year maybe. This is identified by the color coding. Color coding is nothing but a source of the energy, because as on date we get the hydrogen by hydrolysis of the water. So hydrolysis of water consumes huge amount of electrical energy. So hydrogen is a good option if we are using the energy from the green sources. If we are using from the carbon related sources, then it is a waste of energy, I'll say. So hydrogen is good, again repeating, hydrogen is good if it is produced by the green resources. Otherwise, it is not viable or not this thing. So otherwise, it is leaving a bigger carbon footprint. So green hydrogen means produced from the renewable sources. Blue is from the produced from the this pyrolysis process of methane. Sorry, turquoise, that blue is your from the carbon capturing and methane and coal. Gray is from the fossil fuel. So for different coding, but of course in future we need to focus for the green hydrogen only. There is a national green hydrogen mission running also, the obvious, and there is a already statutory requirements has been implemented on the steel plants and refineries, where hydrogen was surplus once upon a time or methane was surplus once upon a time. They have been instructed to use 20% of their energy needs from the hydrogen only, in fact, and that hydrogen need to be produced from that methane, breaking the methane, CH4 in carbon and hydrogen, use that hydrogen as energy. That is what is the right way. So, of course, India is also taking so many proactive actions for this hydrogen energy utilization and hydrogen energy. Even our Transport Minister Nitin Gadkari has declared in this 2024 they will start at least 2 trains run by the hydrogen energy, you can say. Once the trains are started, then of course in between so many cars are also coming in the market. Like Toyota this year has launched 7 cars which are running by hydrogen only. So gradually we may see that. Here is a common kind of the comparison for lead acid, lithium ion, sodium sulfide, flow batteries, flywheel, compressor pumped hydro system. So we can see that lead acid is having very good efficiency. Lithium ion is also having very good efficiency. The only thing is lead acid is not mobile friendly, I'll say. It's bigger in size. And lithium ion is mobile friendly also. So that is why its application is more in even in EV, even in mobile, even in laptops, and even in all other portable devices, you can say. So now is the time where I would like to conclude with some remarks. Already I quoted some of the remarks so many times, like lithium ion is the winner as on date, while hydrogen is the future winner. The substitute of lithium ion may be lithium air, that is quite environment friendly as well as cost friendly, is expected, not yet applicable in the commercial applications. And the life cycles and dynamic performance are some of the parameters we need to see. And the governments are tightening the stringent norms for any side effect of the battery applications, electrochemical batteries, in fact. So that is why I am again saying that hydrogen may be the winner. From my side, I conveyed so many things. Now I'm open for any queries or questions, whatever is there. Thank you. Thank you for patient listening.
Thank you. Thank you so much, Dr. Yogesh Gupta. It was a nice overview of energy storage systems. And of course, the topic is vast, and we can again have in future sessions where we can discuss each one of them in detail. And now I open the floor for the questions. So if you have any questions, you may type it in the chat box or raise a hand so that I can open the mic for you. Any questions? Yeah. By the time anyone types the question, yeah, there's a question, I suppose. Yeah. So Mr. Nageshwar has asked to share the PPT. So as I would like to
see that. No
all
issue.
presentations, we are putting it on our YouTube channel, and we will share the link on the LinkedIn page also of this presentation. And if anyone wants to know in detail, can get in touch with Dr. Yogesh Gupta specific questions. But if you have any questions right now, we can take it up. In the meantime, I also have one question. Like Dr. Yogesh Gupta, when we say when we have the installation, solar installations, right? And if it is an off-grid installation, so we need large amount of batteries and
Yes.
lot of space. So,
Yes.
is there any provision or any new technology wherein we can use lesser space for the same? I mean, compact storage systems are available for the. So, I'm talking specifically for the electricity generated through solar.
Yeah. Now you are precisely right. Electricity generated through solar. In fact, when you told solar, then I simply wanted to say instead of electrical batteries, go for the thermal batteries. So the thing is, when we are talking about electricity, as I told so many times, lithium iodide is good, but not because it will be cost. It is not cost economical. So either lead acid people are using or your this sodium sulfide. And for bigger application, iron flow batteries are required, which consumes a huge area, but it is cheaper option, economical options. So as on date, there is no, I'll say, single solution applicable, and we need to wait for some more time if lithium air batteries are coming with the economical cost, because that can store 10 times more energy than the lithium iodide. Then it may be viable or maybe most common solution for the all applications. And as on date, for the grid application, iron flow is one of the most popular, or sodium sulfide is one of the most popular.
Thank you, Dr. Gupta.
Yeah.
Do we have any questions? No. So we do not have any questions. So
Okay.
thank you so much, everyone, for joining this session. And we hope that you will keep on joining our future sessions also. And like, if you have any feedback about our sessions, you can directly write to us or on our email, that is awewesternindia@gmail.com, or send me directly on WhatsApp, that is 982307170. Thank you once again, Mr. Gupta, Dr. Gupta, for sparing your time and enlightening us with energy storage systems that are available. And we hope to continue our association in future also. Thank you so much.
Thank you. Thank you.
Bye. Bye for now.